In this lesson, we are going to learn about confidence intervals with the difference of two proportions. So obviously we know how to find a confidence interval for just one proportion. When might we want to use two? Obviously when we're going to compare two groups. We want to see how two groups differ from one another. So say it's a treatment, is it better than a placebo? This year versus last year, situations like that where we might want to see if there's a statistically significant difference between two groups. So again, we know that if we're going to examine the difference between two proportions, then we need the standard deviation. But just as before, quite often we're not going to know the standard deviation, the P, the proportion of success or the proportion of failure for the actual population. And so we're going to have to rely on our P hat, which is of course our observed proportion of success and our observed proportion of failure. But notice I've got two groups here. So I need to do my P hat Q hat over N for my first group, do the same for the second group, and then I'm adding, because remember, we always add variances. Every single time we're going to add variances. So even though I'm actually going to be finding the difference of two proportions in my test, I'm going to add those variances and then take the square root, which of course turns it into a standard deviation, or in this case, a standard error, since we're dealing with P hat and Q hat. So this is going to be the standard error that I use. Just as before, we're going to check our conditions. I'm not going to focus a ton on those because we've learned those in the past. I do want to note that here we have to check for both proportions. So are both proportions randomly selected? The 10% condition for both. This one is a little bit different because it's not just independents, it's independent groups. So we're saying the group is independent from the other group. So the groups have to be independent of one another. And then again, sample size, you have to check it for both. Now, of course, for the mean, we're just going to take our P hat for our first proportion and our P hat for our second proportion and subtract them because this is a difference of means. Do yourself a favor. Take this one, make this one your bigger one. It certainly works if you have a negative, but I always like to make that first proportion the bigger one so that when I subtract that I've got a positive mean. Otherwise it gets a little bit tricky trying to figure it out. Standard error, of course, if we could do standard deviation, we would, but standard error is probably what we're going to deal with, which is my P hat Q hat over N and P hat Q hat over N, and then taking the square root. Remember, we're back to the normal model because we're dealing with proportions rather than means, so I can write it as a normal model. And now this is essentially how we would set up our confidence interval. So we would find the difference of the two proportions. Again, do yourself a favor and make P hat 1 be the larger value. Z star, those are back to our normal Z stars, so we're using that 1.645 for the 90%. We're using 1.96 for the 95%, etc. And then, of course, this is our standard error for proportions, so we're just going to put it all together. Now, for this first question, we're looking at who do we think are more intelligent, men or women? And of course, to do this, we're just going to ask a bunch of people. And this is a Gallup poll, so we know it's random. But it's 520 women and 506 men. And 28% of the men thought that men were generally more intelligent. And 14% of the women agreed that men were more intelligent. But obviously, both groups thought women were more intelligent. Is there a gender gap in opinions? So we're not saying who is actually more intelligent. We're saying, is there a gender gap in the opinions about which sex is smarter? And we're doing a 95% confidence interval. So we're going to check the conditions. Note that I'm comparing the groups for independence. So intelligence of men, or I guess I should have said viewpoints about intelligence of men and viewpoints about intelligence in women are independent of one another. 10%, I'm checking both. Success, fail, I'm checking both. Randomization, I'm checking both. And then I say the conditions are met. So we'll use a 2 proportion Z interval. And of course, that should also be a normal model. Now, to do our calculations, I'm going to show you by hand. And then I'm going to also show you on Statcrunch. So let's look at them by hand first. The 0.28 and the 0.14, of course, came from here. 0.28, 0.14. Notice that I said I'm going to put men first, and I chose that because men had a higher proportion and I wanted a positive number here. So I have 0.28 minus 0.14, 1.96 because that's our 95% critical value, and then this is our p hat q hat over n for men and p hat q hat over n for women. Again, do yourself a favor and do all of that at one time in your calculator, but you should end up with 0.0492. Make sure you're not rounding this off to two places. A lot of people are making errors because they're rounding. Don't. And then I'm going to subtract and add. Now pay attention to the conclusion here, because whatever order you put these in, that's going to help you to know how to write your conclusion. So what I was testing was the difference in opinion about intelligence between men and women, and notice I put men first. So the fact that this is a positive means that this is the range or the proportion of men who believe that men are smarter over women who think men are smarter. So here's my conclusion. I'm 95% confident that between 9.1% and 18.9% more men, again because men came first, feel that men are more intelligent than women who feel men are more intelligent. So we're saying this is the proportion that of men that's greater than women, greater because we subtracted. So before we do one of those on our own, let's look at how to do all of these calculations in Statcrunch. So I'm going to go to Stat, as I generally do. Remember, I'm back to proportion stats, but now I have two samples. And on this particular question, of course, I have my summaries because they have given me the proportions. So I'm going to choose with summary. So now notice that it's asking here for the number of successes and the number of observations. So a mistake a lot of people make is trying to put 0.28 here for number of successes because that's the proportion, the proportion of men. But remember, it's 28% of the men, and there were 506 men. So I'm going to use my calculator. I'm going to multiply 0.28 times 506 and put that value here. Now the great thing about Statcrunch is that they will allow you to put a partial person in. If you're using the TA84, they don't, which is why I would recommend using this. Again, notice that I'm choosing to put men as sample 1 because I already know that 28% is greater than 14%. So I took 0.28 times 506 to get 141.68, and again, number of observations was 506. I'm going to do the same for women. I'm going to take 520 multiplied by 0.14, and I get 72.8 out of 520. Again, I'm going to do a confidence interval, and I'm going to do one for 95%, so make sure that you're checking that it's the right level, and then I will compute. And just as before, notice it's going to give me my lower limit, which is 0.091 essentially, and my upper limit 0.189, and I would write the same conclusion. For our second question, we're being asked to determine if people, if attending a weekly meeting along with wearing a patch will help people quit smoking at a greater rate than people who don't attend the meeting. So of course I'm going to check my condition, and I'll let you read through those, but all of the conditions are met, so we'll use a normal model and a 2 proportion Z interval. The calculations, let's pop over here to Statcrunch and just do them over here. Again, I'm going to go to Stat and Proportion Stats and to Sample, and I'm going with a summary. Just as on my last question, I'm given that 32% of the people in group 1 quit smoking and 20% in group 2, but I don't have a number, so I have to multiply. So I'm going to take 0.32 times the number of people in group 1, which is 143, and then I will do the same for sample 2. Notice, again, I chose group 1 to be sample 1 because 0.32 is larger than 0.2. When I multiply 151 times 0.2, I get 30.2 out of 151. And then again, I'm going to do a confidence interval, and it's going to be 90%. And then I'm going to compute. Again, for my calculations, here is that data by hand, but I'm going to just utilize Statcrunch to find the same answers that I had found previously. And then of course my conclusion, I'm writing it as that more smokers will quit by attending a weekly meeting because group 1, the people who went to the weekly meeting, that number was the larger proportion. So I'm 90% confident that between 3.6% and 20.4% more smokers will quit smoking by attending weekly meetings than smokers who don't attend a weekly meeting.